I'm not spending the whole period reviewing because we did that yesterday. But hopefully, hopefully you, if you didn't have to spend any more time last night, that's fine. But spend some time tonight and say, I can do this. I can do these I'm sorry, that's what I'm doing today. I can do these significant figure questions. I can do that. And be proud of yourself. Say, I know this. If you ask me this a week from tomorrow, 2 weeks, a month from today, I'm going to know it. For the exam, I'm going to have an exam this year in December. I'm going to know it. Oh, I'll study it, but I'll know it. So anyway, that's the whole idea, I think, of learning. I had somebody yesterday, we had a couple engineers here for career day, and that was for the seniors. And here are these people that went to school, and they took some pretty hard classes in engineering. And you know what they said? I don't know if I remember a whole lot from college, but I did remember one thing. They taught me how to learn. That was the most important thing that they said in any jobs, because this one guy's job says, I don't know what's going to happen next. What are they going to ask me to engineer next? I don't know it. So it's not like I already know it, but I know how to learn. One guy's a computer person, and he says, they're always changing languages. Says, I know how to learn. I have to keep up with that. And he said, and they both said that. He said, I learned how to learn. Sometimes I think you think school is, just remember that fact, and then you're a good student. Then you're wasting your time, okay? Most facts you can look up, can't you? Learn how to learn. Okay, well today, again, I am going to start what I would have started if everybody had a great grade the first time, but what's going to happen is I'm going to start this lesson today, and this will be, there'll be at least 2 more grades after this bonus thing, okay? So I have 2 more grades, and let's see, and yeah, one will be a homework and one will be a quiz the next week, and that'll end the first 9 weeks. And the end of the first 9 weeks is next Friday, so I feel pretty certain we'll have the bonus opportunity tomorrow, and then you will have a homework and a quiz next week, and that'll be the last of the grades for this. We got that? Okay, so if you have a calculator with you, I would like to go ahead and start today. I love teaching this next thing. I love teaching lots of things, but I really, really love this next thing. And it's kind of weird because it was never taught to me in high school. And I had a roommate in college, and he went to a big high school. Mine wasn't so big. And I'm not blaming it. That's whatever it was. And I'm in college. I went to Purdue University, big, like 30,000 people there. That's a big, big school. Kind of like NC State. And and I'm taking chemistry, and wow, they're doing stuff I've never seen, you know. And I felt like maybe some of you did when taking my my test. But my roommate, he said, "Oh, I use this factor label," and I said, well, "What's that?" And even though he was trying to show me, I was kind of like, I guess I didn't think I was arrogant. I didn't think that, but my mind said, he started to teach it, and I thought, well, if I haven't already had it, it's probably not worth learning. See, that was pretty arrogant, wasn't it? That was bad. Anyway, when I got out and I started teaching, I started looking at this again. It came to me. I actually understood how this worked, and I'm not going to over exaggerate, but I think it's one of the greatest thinking tools that I've ever learned. And so I'm going to teach you a thinking tool, and it's going to help you in almost every math-based science you have. I've had people say, yeah, I took an SAT and I used that on a couple questions. I couldn't do it in my head. I knew how to do it there. And so I've had people come back from college and said, keep doing that. We do factor label all the time. I don't even tell them. I don't ask them that. They tell it to me. They'll tell me, yeah, we're doing factor label. And almost every one of those kids may have even taken AP chemistry, and yet they didn't really understand factor label. And so some of my students will say, yeah, I had a group where I was teaching them. I was teaching them factor label. I love hearing that. It's not about me. It's not about me anyway. But the fact that they had this tool that they could really use, then that was great. I loved hearing that. All right, a really bad joke, but I'll tell it anyway. You know what? I was just thinking about tools. And I was at Home Depot the other day, and not really, but I was at Home Depot the other day, and this guy came in, he was angry, and he slammed this chainsaw down on the counter. He said, I want my money back. And he says, what are you talking about? What's the matter? He says, that's a terrible tool. And he says, really? That's one of our best chainsaws. And he says, no, I had to cut down a tree this big. It was only this big. It took me like 4 hours. And he says, sir, I don't understand that at all. They said it should have taken like almost no time. And so the guy said, let me check it out. So he goes like this. He goes, and the other guy says, what's that noise? Now, the joke is, if I hand you a tool, but you don't know how to use it right, it's not a very good tool, is it? What was that person doing? Okay, wait a minute. Does everybody understand now? I'm going to give you a tool, but you have to know how to use it. All right, so let's start with it. And this is, oops, down here. The name of this is called Factor Label. And Factor Label is a way to convert. Oh, I should have this on. You're right. Okay, sorry. Factor Label okay, anyway, so it's called the Factor Label method. And what I did is, even my advanced chemistry class right now, they're still using that tool. And I had people that, like I said, that became nurses. Miss Shaw's daughter, she didn't have to come and tell me that. She said, I use that all the time. She's in a neonatal unit, and she has to give medicines to babies that may be only 3 pounds, 6 pounds, something like that. And she said, I'm using this all the time because I have to judge it on their mass, and I have to use conversion to say how much medicine do I give that person. So it's a tool if you learn how to use it. Now, even though last chapter you had this thing called stair step. Stair step can only do one thing. It could convert metric to metric. Isn't that right? It could not go feet to kilometers, could it? It couldn't. So, so this is so powerful of a tool. It can do all that, of course. It can convert anything. I can convert euros to dollars. I can convert almost anything that can be converted. I can do that for you. I know some of you are thinking, I'll just pick up my phone. Siri. I understand that. You could do that as long as you have your phone. Okay, let's take a look at, and what I'm going to do is, I'm going to start with the first problem, and here it goes. And I know there's 2 ways to spell donuts, but that's okay. So, here it is, this great thinking tool. And what's the first problem we're going to solve? 18 donuts equals how many dozen? And you could be looking at me saying, don't waste my time, Mr. Feeney. I already know the answer to this one. Why would I pick a problem that you already knew the answer to? What do you think? Isn't it true everybody here knows the answer already? Okay, why would I pick a problem you already know the answer to? I'm not concerned about the answer. I'm going to get the right answer, but I'm concerned about another way. I'm going to show you a new way of doing it, and then what's going to happen? I'm going to give it down here. 50 grams of sulfur equals how many atoms of sulfur? All right, go ahead and do that one now. If you learn how to do the donut problem, you will be doing one of these chemistry. They even do this in college chemistry. You'll be able to do this problem today also. Learn this method, apply to this one, and you say, wow, I can do that? Okay, here we go. So what I'm going to do is I have to figure out whether or not you are worthy of me teaching this to you. What? So what I'm going to do is I'm going to give you a little quiz to see if you're worthy. Okay, so here we go. Quiz question number 1. Do you believe that any number times 1 equals the original number? Let's just try that. Do you believe that any number times 1 gives you the original number? That's quiz question number 1. Now, some of you are a little too fast. Did you try 0? Did you? Did you? Did you try a negative number? No. Try them. Try 0. Try a negative number. How about negative 5 times 1? Does that equal negative 5? All right, quiz question number 1. Do you believe that any number times 1 equals itself, the original number? Ding, ding, ding. Okay. You passed the first quiz question. Quiz question number 2. Do you believe that 12 donuts, I'll spell it like the other way. Donut. Do you believe that 12 donuts equals 1 dozen donuts? Okay, what do you think about that? Is he trying to trick me here? Is 12 donuts equal to 1 dozen donuts? Okay. Now, some of you may have heard about a baker's dozen. You know what a baker's dozen is? 13. And that's the idea that if somebody wants a dozen and you're throwing them in there real fast, the worst thing you could do is give them less than 12. Is that correct? So if you thought you miscounted, what do? You throw another one in there. And that's why a baker's dozen is 13. But we're not talking about a baker's dozen, are we? It's like going to McDonald's and you get a 4-piece McNuggets meal. And then every once in a while, if they gave you 3, you'd be angry, wouldn't you? Well, every once in a while, don't they give you 5? You see? It makes you feel better, doesn't it? Okay. All right. Do you think that 12 donuts equals 1 dozen? Ding, ding, ding. Okay, there we go. Quiz question number 3. Do you believe, except for 0, that any number divided by itself is equal to 1? Except for 0. Do you think that any number divided by itself is 1? Try it. Is that true? Is that true? What do you think? Do you believe that except for 0, that any number divided by itself is equal to 1? Ding, ding, ding. Okay. All right. Well, now you only have one more to do. You have your final exam. Now, I'm going to give you one final exam question, and you may not ask me any questions. You may not talk to anybody. You may not see what everybody else writes. You have to write down what you think the answer is, and you're going to cover it up. If your answer has a number, put a number. If it has a unit, a label, put it on there. If it doesn't, leave it alone. Are you ready? All right. You ready? Final exam. All right, begin. Begin your final exam. Don't ask me any questions. Don't look at anybody else's paper. When you're finished, cover it up. Everybody done? Is everybody committed to an answer? Are you all right? Okay, we're going to go right down the road. Lacey, you're going to... Now, I want you to be absolutely honest with me, okay? I'm not going to say the answer is right or wrong. Just tell me what you had as an answer. Now, I've done this 30 years, and I know what's typical. So just make sure whatever you wrote there, all right, if it had a number, it's a number. If it's a number and a unit, all right, that's all I need to know. I believe we'll get at least 4 different answers. What do you have? One, just one? Or just one donut, 1 dozen? What do you have written down? What is it? I'm sorry, what is it? 1 dozen. 1 dozen. Okay, is that what you had? 1 dozen. What do you have? 1 dozen? What do you have? That's called peer pressure. Are you absolutely sure you had that? Okay, really? I don't believe you had 1 dozen. I didn't even say that was the answer, did I? But you're feeling pressure, aren't you?
I had just 0.
Okay, 0. I want to see that. Okay. Okay, what do you have? 1 dozen.
Said 1 donut.
Okay. All right.
I said 12 donuts per dozen.
Okay. 12 donuts. Wait, you put 12 donuts what?
Per dozen, like
Oh, well, you just copied what I had. Okay. Yeah. Well, I'm not saying you can't copy what I had, and that's in a way it's right, but it's not. I guess I'm not going to put that one. Well, okay, I'll put it down anyway. Okay, what do you have?
1 donut.
Oh wait, we already had that.
Same thing.
Say it again.
1 donut.
1 donut.
I had 12.
12 what? Oh, over here. Okay. 1 donut. 1 donut. Okay. This is very typical. 1, 2, 3, 4. There are 4 different answers. I thought it might be 5. Okay. All right. Let's take a vote. How many people think, after looking at all these, how many think the answer is 1 dozen? Raise your hand and keep it up. 1 dozen. 1. Are you really only 1 person? Really? Okay. How many people say it's 0 donuts? Okay. How many people say it's 1 donut? And how many people say it's 12 donuts over 1 dozen? 2, right? 3? Okay, 3. All right. So what I want to say is the reason I'm going into this is I want you to know how this works, how factor label works. And these little questions are essential. And I will tell you that the answer, nobody got the answer right. So, as a matter of fact, I don't want to say you're a liar, but you have to be a liar because you told me that 12 donuts was equal to 1 dozen donuts. That's what you said. You said that, didn't you? And you told me, except for 0, anything divided by itself is equal to 1. This has to be 1. It has to be 1, not 1 donut, not 1 dozen. It can't be anything except 1. You see that? Now, what do you think 1 dozen over 12 donuts is equal to? It has to be 1. It has to be. Now, this is the weirdest looking 1 you've ever seen, but this is the key to factor label. We're going to build these things here, and these things that I built are called conversion factors. Now, what do you build conversion factors out of? You build them out of equivalence. Now, equivalence is a fancy name for saying things that are equal to each other. If they're equivalent, they're equal to each other. You get that? These are equal to each other. They're equivalents. Now, look at this right here. This equals that. How many conversion factors can I make? 2, with donuts on the top and dozen on the bottom, dozen on the top, donuts on the bottom. I can make 2 conversion factors out of that, can't I? So now I'm ready to teach you how to do the problem. Everybody ready? Step 1. Step number 1 is write down the given. Sorry. Step 1, write down the given. Now, what's the given? 18 donuts over 1. What? Yeah, I'm sure your math teacher told you 3 is the same as 3 over 1. Haven't they said that? Well, what's 18? That's 18 over 1. What's donuts? That's donuts over 1. And the reason I'm telling you that is I want you to know the number and the unit, also called a label. The unit and the label are both in the numerator. You have to know that. Okay, I got it. Step 2. Step 2, multiply the given by a conversion factor. Conversion factor? Like which one? And I'll show you how you know. All right, watch. In order to make this conversion, this label has to go away. The label called donuts, it has to disappear. How can you make the label donut disappear from a numerator? How do you, and by the way, I'm going to have you write given here just for a while, and then after a while, I'll make, you don't have to do it. And I'm going to write CF here, conversion factor. Now watch this. This is almost unbelievably how easy this is. What label has to disappear? Donuts, right? But it's in a numerator. How do you get rid of donuts in a numerator? You multiply by something that has donuts in the denominator, don't you? What label would you like to replace donuts with? Hang on, I'll tell you. Dozen donuts. All right, you got that? Is everybody okay? Now, if we have an equivalent here, we can build a conversion factor. Now, you're either going to use this conversion factor or this one. And how do you know which one? Guess what? The one that has donuts in the bottom. This has to equal that. Now, why is that? What's that? Why? Because math says, does math say I can take any number times 8 and it equals the original number? Did they say that? If I go down to my bank, I say take all the money in my bank and multiply it times 12. They'll say, no, sir, we can't do that. Can I go down to my bank and say, multiply all the money in my bank times 1? And they'll say, it's done. Because in math, you can multiply anything times 1 and it still equals the original thing, doesn't it? And all conversion factors equal what? All conversion factors equal what? 1. That's what allows me to multiply the given times a conversion factor. This is mathematically legal. Now, I don't know why, but some people get this far and they put the wrong number in the wrong place. This is not hard. Watch. I do not use the problem to do this. I use things that are always equal. See that? If this was 8,000 donuts, I would still use the same conversion factor. You get that? Don't use this to build this. Okay, now, next thing. This has to equal that. 1 dozen equals what? 12 donuts. I'm going to tell you how serious I am about factor label. Okay? If I made this a 5-point problem, I will give you 4 points for factor label. I'll give you 1 for the correct answer. 1. So if you were to do it correctly and somehow you punched in the calculator wrong, you'll still get 4 out of 5 points. Or if you think you want to do it some other way and you give me the answer, I'll give you 1 out of the 5 points. Now, when you get to be big boys and girls and you're out of here, you can do problems any way you want. But for right now, when I grade this, I'm graded on factor label method. So you have to use this method. I'm going to force you to do it until you get good at it. Now, here's what's key. Part of factor label is this. I'm going to factor out, you call it cancel. I'm going to factor out, I will give you points for taking a single line and crossing out the labels. Get that? If you don't cancel out the labels, I'll take half a point. Now, I'm going to show you something here. What is the only label that's not canceled? When the only label not canceled is the one you want, that is the only time you put equals. You do not put equals. That's another thing I see every year. Somewhere in math, they do these things called proportionalities. 1 is to 2, as x is to 5. And have an equal sign between, right? That's not what we're doing. I'm not doing a proportionality. I'm multiplying this times this. You do not put an equal sign there. But when the label is correct, I'll put equals, and then I'll quickly remember, I'm going to do you a great favor. If you ever leave the label out of anything, I will take off a point. That's a great favor for you. You will learn how to do this, and you'll say, I didn't know that labels are so important in science. They are. I bet when you took that test Monday and you saw something that block and it said 130.5 grams, did you understood that that meant mass? What did G mean? It was grams, right? Knowing your labels is very important in science. All right, so now what do we do with the calculator? And I'm going to show you a little lesson here. If it's in the numerator, you multiply by it. If it's in the denominator, you divide by it. We don't multiply or divide by 1, it won't change anything. So you're going to put 18 divided by 12 equals. Let's do it. Ready? Let's do it. All right, so what do you think? Now again, everybody knew the answer before we started, but you would not have done the problem this way, would you? But you might think you're so arrogant, like I was too. You might be so arrogant and prideful, you said, you have nothing to teach me today. I already know how to do that. Okay, go ahead. I'm ready. Do it. Do this one. I'm ready. All right, here's what we are going to do. You're going to do this problem right now and do what you're supposed to do. Ready? Go. 50 grams of sulfur equals how many atoms of sulfur? Ready? Do what you're supposed to do. Okay, now you're not doing what you're supposed to do. I know you're not. Nobody has raised their hand. You're not doing what you're supposed to do. You might as well stop because you're not going to get this problem right. You're not doing what you're supposed to do. What should you be doing right now? Yes? That's what you should have done. You should have asked me for equivalents. Equivalents are the key to building conversion factors. Did you get that? You should have said, what is the equivalence of grams to what? Atoms? That's what you should have done. Okay, here we go. Even though this is taught in chapter 7 in your book, I'm going to teach you a little bit of this today. A little bit today. And I'm going to tell you about this thing called the mole. And you don't even have to know what a mole is. You don't have to. It's going to work anyway. 1 mole of sulfur equals, it's a strange number, 6.02 times 10 to the 23rd atoms of sulfur. As a matter of fact, I could do this for any element. Let's do another one. 1 mole of carbon equals 6.02 times 10 to the 23rd atoms of carbon. I could do it for every single element on the periodic table. The first 2 equivalents is the same. They're all the same. Matter of fact, next Friday is Mole Day. Now, Mole Day, just like math people, they love March the 14th because March the 14th on the calendar is 3/14, which is 3.14, and they call it Pi Day. And a lot of the math teachers here, if we have school today, they might make a pie or something like that. They love Pi Day. Well, chemists have a day called Mole Day. Now, Mole Day is 10/23. 10/23, and And you're supposed to get up at 6:02 a.m. or 6:02 p.m. and yell out, "It's mole day!" So I want you to remember that next Friday, because that's mole day. So what is this number? It's called Avogadro's number, 6.02 times 10 to the 23rd. Now, there is another equivalent that goes with these. And I will give you a periodic table on the next quiz. And I want you to look up here, and let's take a look at sulfur. And we see the big numbers like 1, 2, 3, 4, 5, 6, 7. We're not looking at those today. We're going to look at the decimal numbers. And I don't know if you can see that or not. You see that 32.06? Okay. From the periodic table, 32.06, and guess what you put after that? Grams of sulfur. Now, let's do the same thing for carbon. What would you put for carbon? 1 mole of carbon equals 6.02 times 10 to the 23rd atoms of carbon equals 12.01. 12.01 grams of carbon. Oh, that's interesting. And we'll have a whole chapter on this. I'll tell you some more about the mole concept and all that kind of stuff. But this is all I want you to teach as far as that chapter. That's as much as I'm going to teach, okay? Now, let's play the game. The reason I think I didn't want to learn this the first time because I was so like math. I like math. You get it? And everything was about numbers. And no science teacher made me do anything with labels. If I left the label off, I still got full credit. I never got marked off. That was a shame. I wouldn't have liked it back then, but I might have learned my lesson. Then when I got to college, I didn't pay attention so much to labels, and that hurt me. That hurt me a lot. And so what happened here is I'm going to show you how to do this, and this is what's going to be hard for some of you. Trust the labels, not the numbers. The numbers will take care of themselves if you take care of the labels. So forget the numbers for a minute, okay? Now, watch right here. What label has to go away if you're going to change grams to atoms? What label has to go away? Grams of sulfur in the numerator. That's why I put grams of sulfur in the denominator of my conversion factor. And what label would you like to replace it with? Atoms. Atoms of sulfur. Yeah? Now, what we do is we got to have some numbers put here, right? We go to our equivalents. Now watch. I'm looking for grams of sulfur. I'm going to be kind of silly here because people remember this. That's all right. I'm old enough I don't get embarrassed too much. But right? So I want grams of sulfur. Look. No. No. Yes. Okay, so what number are you going to put next to grams of sulfur? Yes. Now, I don't know why, but every year somebody puts the wrong number there. And I have to ask you, how did you do that? Now, what am I looking for now? Atoms of sulfur. Ready? No. No. Yes. Now, don't put the numbers in the wrong place. How do you do that? Now, double check. Does this equal that? Does this equal that? Does this whole conversion factor equal 1? It doesn't look like it is. It does. It has to. Except for 0, anything divided by its equal is equal to 1. I'm allowed to do that. I'll give you credit for that. I give you credit for marking that out. And now, the only label left is the one I want. That's when I put equals. Atoms of sulfur. Okay, now, let's do it. Find it. You can do it now. So, in your calculator, here's how you're going to do it. Watch. This times this divided by that, enter. If it's in a numerator, you're going to multiply by it. If it's in a denominator, you're going to divide by it. Now watch, wait, look at me. You can do this times this divided by that. If you get bored, this divided by that times that. It'll work. You can try it both ways. Try Try it both ways, and you'll see how it works. All right, you done? Let's see. All right, Caroline, what do you have?
I got 9.4 times 10.
And we'll always say with 3 sig figs. What, 9.4 or something else?
Sorry, it was 9.39.
And what's after the 9?
It was 9.388.
9.388. So 9.39. So we do 3 sig figs. And is there an E somewhere?
Yeah, times
E means times 10 to the, and what's the number?
23.
23. You just did a problem that they do in even college chemistry. We'll do it also. But we did this by using this method here. If I ask you right now, let's do another one. Let's do another one. Let's do another one. 50 grams of carbon equals how many moles of carbon? And you say, I don't know what a mole is. It doesn't matter. It doesn't matter. You're still going to get the question right. That's how powerful this is. I can get it right and not even know what a mole is? That's right. Let's try it. This should be automatic right here. See this right here? Grams of carbon? Yeah, automatic. Whoop! Grams of carbon. Automatic. Even before you look up any numbers, you get that? That label has to go away. I don't try to cancel a number. I just try to cancel a label. You ever got that? What do you want to change it to? Moles. Carbon. Okay. Where do I get my numbers for this? Equivalence. You use equivalence to build conversion factors. Let's go up here. Moles. No. No. Yes. There's a 1 there, isn't there? Now I want what? Grams? No. No. Yes. Cancel. Cancel. I only put equals. I only pick up my calculator when the last label is what I want. All right. Let's see if, Ty, I bet you got this done already, doing?
4.163.
One what?
63.
Well, get it again. 4.133?
63.
63. Okay, so we'll use 3 sig figs, right? What do you think? You don't even know what a mole is, but 50 grams of carbon is 4.16 moles of carbon. Wow. All right, so let's go a little higher level with you guys. Let's do something a little higher. Ready? A equals B equals C. I just gave you that. I just gave you that example. Look, A equals B equals C. How many different conversion factors can I make from these 3 equivalents? Okay, what do you think? Give me some numbers. How many people think I can make only 1, 2, 3? Really? You think it's more than 3? 4, 5, 6, 7? How high am I going to go? 10? More than 10. More than 10. Raise your hand. More than 10. None. Let's try it again. I can only make 1 conversion factor. 2. 3. Okay. 4. 5. 6. 7. 8. More than 8.
You like repeat the question, like the whole question.
Okay, if I tell you that A equals B equals C, how many different conversion factors could I make? Everybody got that? Let's try it one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8. More than 8. Raise your hand. More than 8. Okay. All right. So what's that tell me? You're not sure, are you? All right. Could I make a conversion factor that's A over B? Could I? I could. Could I make one that is B over A? Oh, yeah. Could I make one that was A over C? Yeah. Could I make C over A? Yeah. What else? That's it. How many? And guess what? Every one of them has to equal what? 1. Every one of them. So if you took this right here and you said 1 mole of sulfur divided by that would be a conversion factor that equals 1. It wouldn't look like 1, but it is 1. I could do this over that, or I could do this over that. I could do this over that, or this over that. This over that. See? 6. I can make 6 of them. So when we go up here, and I have these 3 equivalents, I know what bothers some of you. You say, hey, you had these 3 equivalents, but you use grams and atoms, but you didn't use that. We're not going to use it today. How about this problem? There's 3 of them. I can only use 2 to make a conversion factor, right? There's always 1 I leave out. There's always 1. All right, so what we do is, I'm the only person that, I know I am who teaches this way. I know. I've seen the way other teachers teach it. They kind of do it like some books do. And don't do this, okay? I've seen this called the railroad track method. They'll go, whoop, 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 okay? And then they'll start putting things like that, and students just kind of copy it like a tic-tac-toe board. And then you ask them, like in college, like they'll say, well, let's do factor labels. I don't, I forget how to do that. Because they didn't know exactly how it worked. They were just kind of mimicking the teacher. See, don't mimic me. You think your way through this, and you'll be all right. Type 1, I'm the only person who calls them this. Type 1 means that you're only going to use 1 conversion factor. So let's try one. What you could do is you could put your weight in pounds, or if you don't want to write that down, you write somebody else's weight. Or you could try to estimate my weight. Ooh, that'd be fun. Okay. But you could put any weight you want in pounds, and we're going to change it into kilograms, okay? So go ahead, put however many pounds you are. Let's say, I don't know, maybe some of you weigh 140 pounds, some of you weigh 100, some of you weigh 90. Okay, so guess what? So here we go. 140 pounds equals how many kilograms? Okay, so if you go anywhere on the world and they want to know how much you weigh, they won't understand when you say pounds. Okay, so let's go ahead and convert your weight into kilograms. All right, here's your given. And what do? You're going to multiply by what? What's it called? Conversion factor. And this is a no-brainer. This part is a no-brainer. Look, pounds have to go away in the numerator, so I put it down there. Everybody should be this far. Now you should be asking, I need the equivalence. I will give it to you. 1 kilogram equals 2.2 pounds. All right, go ahead and do it. Now, if you happen to use your own weight, you'll know how much, you can tell anybody else in the rest of the world how much you weigh in kilograms. All right, here we go. It says here, and don't put the numbers in the wrong place, please. I'm serious. Don't do that. What does it say here? I'm not going to use that. I don't use the problem to build equivalence. To build a conversion factor. I don't use the problem. I use my equivalence. It says 1 kilogram is the same as 2.2 pounds. See, this is so nice because I don't have to remember, let's see, do I multiply by 2.2 or divide by 2.2? I don't have to remember that. There it is. I'm going to divide by 2.2. I'll give you points for this. And can you give me a hit on the calculator on this one? What's 144 divided by 2.2? Max, go ahead.
She said it was 63.636.
Okay, and I'm gonna probably have everybody round to 3 sig figs, so we'll keep it at that. And so if I go around, if that person goes around the world and they say, how much you weigh? About 64 kilograms. See? They'll understand. They'll understand that. What do you think? All right. One more. Type 2. Type 2. Type 2. Same idea, achieving more than one conversion factor. All right. I was at the hospital the other day. Not really, but it makes Storyberry. And I was looking at the babies, the brand new babies. I mean, they were really new. They won't let me go in it right now, but I had to make a story. And I saw a baby that was 6 hours old. And I just couldn't help by thinking to myself, man, how many centuries old is this baby? And that was my question. A 6-hour-old baby equals how many centuries? So how many centuries old is that baby? Okay, are you ready? Here's my given. Now, what I'm going to do is, none of you know the equivalent of hours and centuries. You do not do any side calculations in factor label. No one does any. You're going to use equivalents. Use the equivalents I give you, and we're going to set it up. Now, you don't know hours and centuries, but you know hours and something else that's getting closer to centuries? What do you know? Hours and what? You know hours and days? Do you know that? Let's do that. What do you know about hours and days that are equal? Let's see. 1 day is equal to what? 24 hours. Okay. Cancel. Now, are you done? Are you done? Days. Are you done? If you're not done, you build another conversion factor. Now, what do you want to get rid of? Days up there? Well, I know how to do that part. I don't know days and centuries. What do you know? Well, I know days and years. And a year is actually 365.25 days. And that's why you know that every 4 years, 0.25, 0.25, 0.25, we have to add another day. You know what? We don't add another day. We just don't call the next day February 20, after February 28th. We usually call the next day, what? March 1st, don't we? But every 4 years, we don't call the next day March 1st. We say, no, you're February 29th. And that's how we do it. That's how we take care of this. And it's called a leap year. It happens to be all of our elections are on leap years. All the leap years is evenly divisible by 4. 2020. This is not a leap year. It is an election year. Okay. So now, am I done? No? Okay, here we go. You got to get out here, years. Now what? Are we getting close? Do you know years and centuries? 1 century is equal to 100 years. And I'm going to show you one more little trick about this. If you want these to be equivalent, if you know a century is bigger than a year, you can't give the big number to the big unit. It will never equal this, you get it? So if you have the big unit here, he's got to get the small number to equal this guy. So you're going to make that mistake, and you got to catch it. Don't say 100 centuries equals 1 year. That's the biggest mistake. Now, here we go. I'm done. I'm going to put equals. Now, I know you don't like this. This is the last thing. Give me 30 seconds. You're not going to like this because someone taught you how to use a calculator the way they would when you were young. Here's what they do. Multiply, 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 write down. Multiply, 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 write down, and then divide. Don't do that anymore. Don't do it anymore. And here we go. Ready? It's this divided by that. Divided by that. No. Yes. If it's in a denominator, you will divide by it. It's this divided by that, divided by that, divided by that. If you do that, you will get it right. But they told me to. Yeah, so you were young. I do the same thing. Multiply right down. Multiply right down. All right. If it's in a denominator, you divide by it. All right. As soon as you give me the answer, you can leave. Who's got it? Yes.
6.57.
10 to the what? I don't think so. That's a lot of centuries. It's going to be a negative, 10 to the negative something. Who's got it? All right, we got Ty. I'm going to erase that.
I got 6.844 times 10 to the -6.
Negative 6? Yeah, I sounds right to me. He's about a millionth of a century old. That makes sense to me. All right, hey, you did a good job. Good job. And tomorrow, like I said, probably will only take about half the period. We'll see. And I'm going to give some incentive. Even if people did very well the first time, you now have more incentive to say, wait, I could get more points than I thought. All right, thank you very much. We have a break now, right? Hey there.
You show me right now the rest of the class.
Wait a minute, I got to turn this off.